All right. So over this workshop, we're going to cover a lot of bash syntax, and in doing so also encounter a few useful bash Unix commands and tools. The information given in this workshop is not exhaustive. So if we've shown you one way of doing something in the terminal and in bash, there is almost certainly another method for doing so. But we have shown you a way, and that's a starting point. And if you want to learn more about any of these topics, I highly recommend that you hop onto Google and run a search for, say, if statements Unix, and you'll be able to find some very thorough articles on that topic. We're going to start by thinking about the structure of a Unix command. And while it might seem readily apparent that they do follow this consistent pattern, I remember being really pleased when I had it explained to me that the structure they follow is one of a verb, adverb, and an object. So a verb is a doing word, an adverb modifies that doing word, and the object is the subject of that modified action. So if we consider the ls command, when we do ls-a to see hidden files on our home directory, ls is the verb, -a is the adverb, and our home directory is the object. And I just find this to be a good way to kind of keep things ordered in my mind if I'm learning a new command, or if I am trying to explain how to use Unix-like commands to a colleague. And I've brought this up because our goal over this workshop is going to be to explore a implementation of a custom function. So this function will work like other Unix-like commands in our terminal. And what it's going to do is give us a sort of a recycle bin-like functionality. So this function del is going to take a file as its argument, and then it'll move that file to a hidden recycle bin directory. And we also want it to be able to take command line options. So if we do -L4, we want to be able to see the last 4 files we have recycled, or if we give it -U2, we want it to undo the last 2 recycles. So to do this, we need a way of defining del, we need a way of passing the input, and then we need a way of performing the file operations. And the reason why this endeavor is sort of even doable in a reasonable time frame to begin with is that Unix commands, primarily, they're designed to take input from what we call standard in. So it's a stream of strings from standard in, and then they return a stream of strings to standard out. And it's that predictable behavior that allows us to do things like filter and pipe between Unix commands. So I'm going to create a directory called recycle. And I encourage everyone to follow along, or write the bits and pieces that you find interesting. It certainly helps me to keep myself entertained. And we're going to cd into recycle bin and create our first shell script. And for this workshop, I'm going to be using the text editor Vim. That's what I'm most comfortable using. You can feel free to use Nano or Sublime Text or any text editor that you are comfortable using. All bash functions, or the majority, start with this thing called a shebang. And it's a pound symbol and an exclamation mark followed by this bin bash. And that /bin/bash is actually the path to the bash interpreter. And what this does is it means that when we execute this script, like a program, the system picks up that line and then knows that it should be using the bash interpreter to run that code. You might also see a shebang with something like bin Python. And in that case, it would be the path towards the Python interpreter. And that's useful for us because given the correct file permissions, which we can do by giving this file the execute permissions. So chmod modifies our file permissions. If you're interested in learning more about that, we can dig into that a little at the end of the workshop. I'm then able to execute this script like any other program on my computer. So without having to write bash recycle bin sh. And the same would go for a Python program. And the first thing we're going to explore, that's really, laying the foundation for this del function, are input arguments. And bash scripts are able to pass an arbitrary number of input arguments. So it's just a list of strings separated by white space. And if we take a look at section 3 of the notes, we see some of the sort of most useful syntax. So we can go $1 to return the first argument. We could also go $pound to count the number of arguments, or to return all of the arguments, we use $@. So if I now go recycle bin arg1, arg2, arg3, some other argument, I see that the first echo is first argument. I've given the script 4 arguments in total, and it's just echoed out those arguments on the last line. You'll probably notice these the quotation mark around that last argument, and that's used because it's a string that is separated by white space. And as we're writing our code, we're going to be mindful of instances where we may have a file path that contains white space. In that case, we use the double quotations around that variable to ensure that that white space isn't interpreted as a separation between distinct arguments. So this is great if we have a bash script and it's doing the one thing, but we're able to use functions to actually encapsulate multiple functionalities into a single shell script. So we're going to start off by defining a del function. Now, one of the syntactic forms of a function is the name of the function. So say del, pair of parentheses, and then this curly bracket, close curly bracket. And inside del, we're allowed to have an arbitrary number of lines of bash script. And this structure may look a little familiar to people who have done a little bit of coding in C. And you'll find that that's sort of that characteristic is scattered throughout Bash. There's just a little bit of almost C syntax scattered in here and there, but never quite goes all the way. And remembering that Bash functions or commands are designed to take input from standard in and then output to standard out. If we want to return an argument in our function, a simple way to do that to standard in is using echo. So we're just going to echo the first command, first variable input into our del function for now. And it's also common practice to use a return statement, returning 0, to indicate a successful execution of the function, and then a non-zero value to indicate a specific error. So then the question is, like, how do I now use this function that is inside the shell script in my current Bash session? To do that, we source the file. So sourcing refers to the reading and execution of a Bash script in the current terminal session. And this is done with this the dot, and then execute command on recycle bin sh, and it will have gone through and defined that function. And now, if I use del and pass it an arg, we can see that the function is now active in our current shell session. You may also see the command source. This functions the exact same way as the dot command. The only difference is that it's more specific to Bash, whereas the dot form is used by a wider range of shells. In the context of Bash, neither of them is better than the other, but if you can choose between using a command that is more portable, and you know it's generally a good idea to err on the side of portability.
I've got a question.
Yeah, fire away.
So in the script we've got, recyclebin.shell, the del function did echo $1, I believe. And
yeah,
so $1, I would normally interpret that as the first argument to the Bash script itself. But here it looks like $1 is being interpreted as the first argument to the del function.
Yes, that's correct. So yes, it's the first in the context of the function. Yeah, it's the first argument to that function.
Okay.
So you could have I'm guessing where you're going, you could have a script that accepts arguments, that then has a function that accepts arguments, and its arguments, the function's arguments, would be indexed from 1 with respect to their input arguments within the shell script.
So when we declare the function del, we've got the round brackets after it.
Yes.
Are those like purely syntactic, or could you put an argument list in there if you wanted?
They are, for the purposes of this workshop and all of my use cases, they're purely syntactic.
Yep, cool. Cheers.
Question. Thanks. We're now going to put bring some structure into our code. So our del function has a collection of different behaviors, and one of the key ways of implementing logical branching in any programming language, and Bash is a programming language essentially, a programming language that's designed to work on a file system, is to use an if statement. And there are quite a few different forms of if statement in Bash, but the most common is if, open square bracket, some logical statement, close square bracket, then some sequence of commands, and then fi, so if backwards. And you'll see this pattern of sort of the statement if, and then the sort of the mirroring of that statement repeated a few times in bash. And these square brackets are actually a reference to the bash command test. So I close out of recycle bin for now, and I look at the manual test. We can actually see a list of all of the logical expressions that are supported. So, you know, for instance, we've got a file exists and we can execute it. There's -x. There's -e is just seeing if a file exists. We are also able to compare integers, strings. We've got -gt is greater than, and so on. So if you're writing an if statement and you can't remember the particular syntax, it's all there in the test manual. And what we'll actually start off doing is writing an if statement that is outside of del, that's going to be run when the file is first sourced. And what it will do is create our recycle bin directory if that directory doesn't exist. And it'll also tell us that the directory has been created. So for this, I'll need the path to the directory that contained recycle bin sh. That's where we've decided to place the recycle bin. So I'm going to call this script-dir, and using the quotes. And this is a portable way of extracting the file path of a executed shell script. I won't go into it too deeply, but if you have any questions about specific parts of it, yeah, please let me know as I go through. So I'm going to use the change directory command to change to the directory containing the shell script. And the reason why I would do this, even though we're assumably already have a file path to the shell script, is that it will return the absolute file path to the folder. And this array, which we'll learn about later, called bash source, its first element will always contain the path to the executing script. Using a semicolon there to essentially create a new line on the same line, printing out the present working directory, and then closing that with a quotation mark. And now I will define my recycle bin directory as the script directory pointing to a hidden folder recycle bin. And what's going on up here with these nested $ brackets is that in a bash script, if I run a command in a set of parentheses, it actually spawns like another bash session. So it'll run those commands in a new shell, new instance of the shell. And by placing that $ in front, I'm essentially like treating the output of that shell session like a bash variable. And when we have that in mind, you can see how we're able to actually nest shell sessions within shell sessions to actually construct fairly sophisticated nested behavior in our a single line of bash script. Now I'm going to check to see if the recycle in directory doesn't exist. And if so, I'm going to create it. And echo now I'm going to resource recycle bin.sh, and we can see that a directory is being created. And I've also incurred an error because I have a function in my script currently that has no content, but fortunately we're going to be fixing that shortly. And to start doing some interesting stuff with our del function, we need a way of separating file paths from options. And to do that, we're going to use regular expressions. Regular expressions in Unix are a sequence of special characters that specify a search pattern. So when you enter in CD home, technically, we're actually performing a pattern match against the contents of our hard drive and our home directory. There's only one object that can match that pattern. And of course, if we're using a star character, which you would have encountered, we're then pattern matching against all sequences of strings. Regular expressions build on this sort of pattern matching by introducing a fairly sophisticated syntax, some of which is listed there in the notes, that allows us to specify the number of repeats, specify ranges of characters. We're also able to define sections of the pattern that we are going to use elsewhere in some other operation. It's very, very powerful, and you can get very deep into them. But for this workshop, we've just listed a few of the most common in the notes. And what we'd like to use them for is to filter out our options. And we're going to be doing that using grep. So I head back into my code. Let's add some functionality into del. What it'll do for now is it is going to echo a list of functions back, pipe them, and pipe that output to grep, which we're going to be using with the e function, which means match to a regular expression. Placing that inside of single quotes. And what we're looking for is a dash, followed by any letter and we want that to appear at least, we want a single letter, so any single letter. And immediately after that, we're going to allow any number of numerical characters. And
Sure. Sorry. No worries.
I will close there. And I've just, as I'm reading now, I've noted an error in the example as given in the notes. So I will correct that afterwards. So just pay attention to what is on the screen. Close that out. Resource, recycle bin, sh. And now, if I pass the del function, say -h, something else, another option, say that sequence, return an error. Time to fix the bug. Now, reason we encountered an error is because the dash symbol is also a special character. So it's generally used to indicate an option. So grep itself is actually seeing that dash symbol and is then passing that open square bracket as an option flag. So to treat the dash as a normal character, we escape it. And that involves placing a backslash just before the character. And there we go. We can see our output. So we can see that -h is matched completely. We have a partial match with a -l, but that K and the 1 don't fit our pattern, don't fit within our pattern, and then the -l4 are matched completely. And crucially, our file and the some other thing argument are completely unmatched. So we're starting to delineate between the two types of input. This would be a great point to for anyone to ask some questions, especially about how to break down or pass this irregular expression, because I did not find them very easy to pass myself when I was first introduced to them, and even now they do often just look like a jumble of horrible looking characters. So how's everyone going?
Am I able to ask a question?
Please.
I was just wondering, with this expression, you put the question mark, so it's 0 or 1 times for the alphabet character. I was wondering, do we want that functionality so that we don't have to put a letter after the dash?
So the question mark is actually doesn't match against 0. So just reading the notes there, I think that's a little ambiguous. So that's something I will correct. So the question mark looks for a single instance of any character.
Okay.
Yeah.
Cool.
And yeah, great question. So we've sort of reached the scenario where now we want to go through our strings and actually perform the sort of same classification sort of step for each of our inputs. So we're going to be introducing another control structure now, which are for loops. And if you've used Python, you've probably used a for loop, but in general, we'll use a for loop when we want to execute the same sequence of commands on some iterable list. And what we'll do is construct a for loop that'll tell us whether or not a given string is an option or probably a path. And drawing from just the general form of a for loop, we are going to use this for input, where input is our variable that'll change with each loop. in our input arguments, we will do a branching statement. So if the input into grep matches our regular expression, where we're using the -e to indicate that we're matching against a regular expression, and the -q suppresses grep's output. So what it's really doing is outputting either a true or a false, depending on whether or not it identifies a match. We will echo that input is an option, and otherwise say that input is probably a path. And it could also just be a sequence of characters to nothing, but for our purposes, we'll assume it's a valid path. Close the if statement, and then close the do loop we've done. Just use echo there, and test it out. And we can see that it's successfully been able to differentiate between our -L4 command, so where we hope that'll eventually list recycled files, the -N command, which we're not actually specifying, but we can see at this point there's no additional filtering occurring, and then these file 1 and file 2. But really, it's not just good enough that we're able to tell them apart. We want to separate out these values so we can treat them differently. And this is where bash arrays come in handy. This is a functionality that is particular to bash and some other more, I suppose, modern Unix shells. So if you're ever in a scenario where you're working in SH, so that is a script that is executing with /bin/sh, you're actually using a different type of Unix shell, and that may not support arrays. However, on most modern Unix systems, you have access to this array functionality. So it's a great idea to use them because they are really, really quite useful, as long as you are aware of that potential compatibility option. So what we'll do is create 2 arrays, one called files, another called options, where we're going to sort our input arguments. And instead of echoing, we will append to the options and files array. Options plus equal input. And files plus equal. And just taking a look at the notes, you have them there. We can see that there's quite a number of options or syntactic options when it comes to arrays. So, it's an iterable array, so we can access them by index, and they're zero indexed, and we're able to, say, capture the output of an ls command into an array. And as we go through the del command, we're going to run into instances where we're going to use these functions to great effect, I suppose. So just taking a look at our modified code, no output. Sorry, you have to bear with me here with some of this. This is the, you are the guinea pigs for some new content. Options. That again. We see file 1 and L4. Now, the reason that has occurred is because we've actually referenced the arrays in a manner that's not syntactically correct. So we're just actually getting the first element of the arrays. So to access an array correctly, we use these curly brackets. And you may have encountered these curly brackets elsewhere in shell script, where you're trying to tell the shell that, no, the variable I'm interested in isn't just $F, but I actually want $files. And there may be some other thing going on which makes it ambiguous otherwise. So we use the curly braces to indicate that we're dealing with a collection, I suppose, and the square brackets with the @ symbol to access every element in the array. So I'm going to source this again. And then now we can actually see that we do indeed have our file 1, file 2, and our 2 options. So I'd say things are going, fairly nicely for our del, program. We're able to pass it the sort of arguments we want. It can differentiate between the two. So now it's time to maybe start putting the scaffolding in place to actually implement some functionality. And we could do this with a sequence of if statements. So we could say if, the if option is a -L, then list. If it is -U, then undo. But that can get, fairly unwieldy if you have a long sequence of if and else if statements. Much better for these cases is the case construct. And so I'm just refinding my spot in the notes. And we're going to just implement a case statement, which will differentiate between different behaviors in our del function. So the standard structure is to have case and then the option. So we're going to do this for some option. And in, again, so in a pattern. So our first pattern will be listing a file with any number of digits afterwards. And here we're kind of relying on the fact that our earlier grep command will have already ensured that the sequence of characters will be a number. Echo list cycle files, and then return success. Close that statement. And then if we see U, We want something that will undo the n most recently recycled files and return success, closing that off with the semicolon. And finally, for any other option for now, we're just going to return an error because that isn't defined. So I'm just going to say error. The option is not recognized. And return 1 as our error code, so something other than 0, because then it's gone wrong as far as we're concerned. And now just close off the case statement. So that's, we close it with ESAC, ESAC, so case is backwards. And we want to do this for every option that is present in our input. So I'm actually going to go through and indent this entire case construct, which I'm doing line by line just to show commiseration for people who are using Nano. And place this inside a for loop. So we could say for option in, now we can use our array options. We will do this case statement. Done. And heading back to terminal, resourcing our function, pressing the up arrow to go to my previous sequence of command inputs. I see an error because I think it's -n is not recognized. But if I remove -n, I see another error. So time to check my code for bugs. If anyone can identify it, that would be.
I think there's meant to be a $ on option. Yeah.
Thanks. Perfect.
You're also matching -q instead of -n.
Sorry, that should be, it should be -u. I introduced a -n earlier on, just out of habit. You know, most command line functions would have a -n, and that just slipped in. Sorry about that.
Also, you're returning after each case, so it's not actually going to loop.
Yes. So you've identified a limitation of our code here. So what we're going to do is really specify that what we're doing is specifying that our del function can only take a single option. And that just simplifies things for us a little here. We'll need to, in the final code, say introduce an if statement further up to count the number of options that we've had, perhaps, to prevent undefined behavior. But trying to pass combinations of options will result in a script that's significantly more complicated, even though the tool would be significantly more useful, I suppose. So yeah, that's a really great observation. And that's actually part of why it's useful to lay out the sort of specifications of your command or program at the beginning. So because I've listed that I wanted to have that behavior with the list and the undo and have them as exclusive operations, I know that I can just rule out an entire section of much more complicated case management.
Edric, can I interrupt? Because I've just, I think I missed the appropriate time to do it, but just want to make a quick note on the different kinds of command substitutions.
Yep. Yeah, please go ahead.
So can you guys hear me? Hello? Hello?
Yeah, we can hear you.
Yep. Oh, good. So just a little note on this. So if people can look in chat, 'cause I'm not going to share screens. So you'll notice that a lot of the time we're doing something of the form dollars with standard braces, and then sometimes we're doing something with the form double braces, and sometimes you might also see two sets of curly brackets, those three, and those are kind of the three main forms of substitution. And to make it simple, what's happening in those cases, in the first case, essentially what happens is when you do a command substitution, you spawn a subshell and evaluate the commands or whatever variables are inside that list in the subshell. With the curly braces, you do it in the current shell context. So that means a lot of your variable assignments are good and everything else. And in the bottom one is subshell, but that's an arithmetic expression evaluation. So just a few little subtleties on those different kinds, because I know it's tripped me up a few times. Which one do I want to use? Do I want to use the current shell context? Do I want to use subshell or whatever? And the most subtle of the subtleties, if you actually go and look into the manual, with the standard braces, the round brackets are treated as operators in the Bash language. So that means that you don't have to use a space to treat them as separate, because they're interpreted as separate characters by the shell. So you can just use them however you want. Curly brackets, on the other hand, are not operators. They're actually expressions. I can't remember what the correct term is, but you do need spaces with curly brackets. And with the double braces, same thing, you don't need spaces. It's just some subtleties in there. And if you're sure, the Bash manual is very helpful.
Thanks, David. That was great. I still need to actually work on remembering some of those subtle differences myself. So we're actually up to a point where I'll just about to a point where I'll pass on to David for a bit. But in order to do that, we're going to just implement just a little bit more of the structure of our code and think about how it's going to really function. So we now have like the branching control structure that we need to control the behavior. So if we find an option, we're going to execute that option if it's recognized. If not, we're just going to pass on by the case statement, and we can then, proceed to recycle our directories. But how are we going to keep track of where is the file originally located? When was it recycled? Well, we can do that with a log file. And that means that our -l and -u commands can use that log file to sort of produce that desired behavior. So to set that up, we are going to head to the bottom of the script. And here I'm actually going to write the piece of code that actually performs the recycling and updates the log file. So finally, the main functionality, we're going to do a loop. This brings a few of the skills together. So we're going to use a loop for file in files. We are going to check to see if the file exists, because we don't want to add information to our log file that's erroneous. And we are going to determine a new path for the file. in the recycle bin directory. And we will identify that file uniquely by appending to it the Unix timestamp. Or prepending to it, the Unix timestamp, current Unix timestamp. And we also want to determine the old path. So we're using the same strategy we used right at the start of our code to determine the path of the recycle bin directory. So spawning a subshell, feeding into the directory of that file. There's a slight typo in the notes there. So the bash source, we want this to be the file. And where was I? Yes, closing that off, printing the present working directory, and then extracting the base name of the file. So this will be the original path, closing that to deal with any white space in the file path. Now we can update our log using echo. And we'll actually just, for good measure, we're going to, as the first entry, right, record the file size. So du is disk usage, followed by the old path. So, and cut. So we're actually taking the output here of du old path, and then cut is taking the first section of the output, splitting on white space. So that first value will be the file size. And our next item in their log file line will be new path, the $. And old path, the $. And we want to send this to our log directory. So we will append or create using the double angled brackets, our log file. So we will put that in recycle bin under the name recycle log. That's great. But on the off chance the file doesn't exist, we won't terminate the running of the program, but we will just let the user know that, file, $file does not exist. Closing off the if statement, and we are done with the loop. So now we can really test the command out. So I'm just going to source file, and I'd like to create a test folder. So make the test folder. I'm going to move into the test folder, and I want to create some files. So to do this, I'm actually going to use a loop just in the bash shell, because everything we're seeing here can actually be just used in a standard terminal session. So for I in command I am looking for is seek. So for I in a sequence 0 to 9, we'll do a touch command. Lowercase file, I think. New line, done. So wherever we're seeing a semicolon, that's sort of equivalent to having a new line in an expression. And if I ls, you can see I've created a set of empty files. Now, if everything's as it should be in our code, I should be able to type file 0, see no error. But if I ls in recycle bin dot recycle log, cat, sorry. We can see we have a record. So 0 bytes because it's an empty file. We have the new file path. We see a little bug in our code there, and the original file path. So I'll just correct the bug in the code. And again, if anyone wants to point out what I've missed, please do so.
It's in the call to date. You've got +%, you need the S on the end.
Exactly. Thanks. So I will just remove the log just to get rid of that erroneous entry. Source it again. And try it now operating on file 2. And we'll cat the log file. And hey, there's everything as it should be. And the great thing about working in the shell is that a lot of its conveniences sort of come for free when we're coding within it. So if I write del file underscore and just the glob expression, it should have deleted every one of the files, but it hasn't, which means I'm probably accessing my array incorrectly.
We haven't actually implemented the delete functionality yet. You're just writing to the log.
Ah, yes, thanks. I missed that. So that's a crucial step. Thanks. Well, we're going to use the move command to move from the old path to the new path. So much for such a simple command. Now I will again delete that log file, resource my script, and then now this is the moment, I hope. And they're all gone. And if I look at my recycle bin log, see exactly as we want, that record of previously recycled files. So this is really, at this point, we have just about everything we need to implement the rest of our del function. But with a bit of hindsight, I know that we would benefit from another function to extract the number following an option. So I'm going to put that into our del function, and then I'm going to pass things over to Adam, who will start to run through org. Now, this function is going to be called getNumber, placing it at the top of our del function. So we can see here we're able to nest functions within functions. And it's going to use variable and option. And again, this is me taking advantage of my prior knowledge. So it's going to echo the input argument, so we just expect it to work with one, to sed. So sed is a stream editor. It takes a stream of strings, pattern matches against that string, and then performs an operation on those patterns. So what it's going to do is we're using S to search for this regular expression. So 0, so anything that is not an integer. So that caret symbol at the top is a negation symbol in this instance. And those two slashes that demarcates our pattern. And then the next argument will be what we want to replace that with. And in this case, we want to delete it. So we want to take -L4 and then just remove L-L, so we're left with 4. And G is just going to do it on the global input, so not just on the first match with a non-integer character. As David describes the usage of org, you'll encounter this in a little more depth. We're also going to use an nlog. Where we're actually reading from our log, and what we're doing is we're determining the number of lines that are currently present in our log file. So what my hindsight is has told me is that we need to make sure that when we execute, say, the -u command, we don't undo more files, the recycling of more files than we've actually recycled. So we're testing the number of our input argument against the number of lines in the log using an if statement. Option greater than nlog. Then we'll return nlog. Else we'll return or echo an option. Close off our if statement. And now I want this to just be a function that's only accessible from within del. So I've just moved all the way down to the bottom of the file there. And I'm just going to unset, so undefine function at the end of del. And that unset command can also be used with environment variables. So moving up to our cases. I can now implement the L command. So for this, we're going to use tail. Actually has a -n option, which is what I've been thinking of this whole time. And get number. On the option. Targeting our log file. Great. I'm now going to close, source, cycle.bin, and test our new command. No such file or directory. Log search. Correct spelling error. Source the file. Test our command. Another error. Well, that's one too many mistakes for me. So I've just
was the
moved.
problem that you didn't source the file from the previous folder that it was in?
Thanks, Josh. Yes, I reckon that is exactly the problem. So
Because yeah, you misspelled recycle on all of the variables that were in there. So changing the one is probably going to create another error.
have I? Yeah, I see. How embarrassing. All right. So that should be changed in both instances of recycle log now. And I'm going to test. That option ran into another error.
You didn't source from the previous folder again.
So I sourced from.
Are you still in?
Sage.
Oh wait,
Yeah.
am I wrong? Okay, I'm wrong.
I was right about that at least.
So I'm not sure if this is the correct bug, but in the get number function, you reference a variable that you haven't defined.
So this $1?
Your log path that you reference, you never define log path.
Thank you. Yes.
Not sure if that's going to fix it, but
That is the exact bug. So I was thinking about the other example, the complete version of the function that I wrote prior to this, where I actually defined a log path environment variable to the log path directory, which I think we can all see is definitely the safest way to go. You write the path once and then never again. But since I've committed myself to the arduous task of typing out, the full path each time, I'll just change that to recycle binder. Thanks, Cal. And source file, fingers crossed. And no such look. Well, look, I think now is a good time to have a short 5-minute break. During this time, I'll track down my error, and when we come back, David's going to pick up for the rest of the session. Thanks. I guess while we're in the break, if you're still around, any general questions about today or any of the bash commands or syntax we've seen so far?
I had a question with how we recognize which parameters that we give options in files. I've tried using the del command with something that's like -na4, which should be invalid as an option and should technically register as a file name, but I'm getting that it's still being recognized as an option.
So that's
just
with,
wondering.
what was the, so dash like 2 letters and then.
Yeah, so something that shouldn't be recognized as an option is being recognized as an option for me.
Mm-hmm.
So if you could try that possibly and see if
Yeah, I'll give
there's an
that a
error on
shot.
my end.
I believe it's because grep isn't matching exactly. So it's
Hmm.
matching for the pattern like dash letter, some number of numbers.
Yep.
And it doesn't matter if you put letters after that, it'll match on that first part.
Well,
Just dash
the
letter
pattern that I
numbers.
have is letter number, so it shouldn't be recognized as that.
Oh, yeah,
So
letter,
what
letter.
what may have happened is I know in the notes, there is a question mark inside of the square brackets, and that should actually be outside of the square brackets.
I have it outside, I believe.
Mm-hmm.
Just double check. Yeah, I have it outside of the brackets.
Interesting. Well, yeah, at the end of the session, if you're up for it, happy to stick around for a bit, have you share your screen and we can go through and identify exactly what's going on, if you'd like.
Yeah, all right. Thank you.
Awesome. All right. So I sort of identified the error. I think it was some combination of yeah, having actually written a misspelt a log file. So, and then trying to cat that. So I'm just going to actually transfer what I have done so far to David, and then he'll pick up from where I leave off. Sorry for the delay.
So for my section, I'm going to start out doing some of the basics and maybe some little bit more advanced stuff with awk. Now, I think I'm going to start off. I'd like you all to have your terminals open and run these commands with me, because I think they're going to be simple enough that you can experiment at each step along the way. And I'm going to ask some people to experiment, and we'll see. Put things in the chat, and we'll see how that goes. But we'll be starting up shortly in a sec. So if you haven't gotten your glass of water or snack, do so now.
To be absolutely honest, we weren't entirely sure if we would get through this much of the function with all of you now. So we've just a little sudden change of plans because we've realized we can, work through everything more rigorously. So I've just sent David the file I've written so far so he can take over and actually complete the function. So over the workshop, we will have honestly and completely actually defined del.
Right. Cool. It's looking good. Good.
Part of the reason why these shell scripts are so useful, despite the fact that some of the operations may feel a little bit clunky as compared to something like Python, is due, well, in part to it being written to deal directly with files, and also because most shell scripts are this thing called POSIX compliant. So POSIX is a standard for sort of Unix operating systems that was developed decades ago. And on a modern Unix-like system, it's possible to write shell that is POSIX compliant. And POSIX compliant shell will execute on any other Unix-like system that is also POSIX compliant. So far, all of what we've learned is POSIX compliant except for the bash arrays. So all of the other logical statements, control structures, and so on could run on a computer from 20 years ago, and fingers crossed, we'll be able to run on a computer 20 years from now. Fingers crossed, depending on how you feel about POSIX compliance, but that is one of the advantages.
POSIX compliance is great because I think the thing about bash is literally any Unix-like system will run it. So it's a lot of confidence, and I don't think there's any other tool. Like, you can't open a Word doc on every computer. In fact, I think the only thing that you can reliably do on every single operating system is open a text file. And even then, sometimes maybe not. Well, if people are ready to go, I'm going to speed run awk. And so if people have their terminals ready and get ready to start slamming in commands, it's going to be good. So can people tell me how awful does the screen look? Do they need things to be bigger or less, smaller, or and if someone could get me audio feedback, because I can't actually have chat up for some reason.
That looks fine for me.
That's fine. Cool. So, cool little tip, Control L clears the screen. So I can, I can go, so I can do something horrendous like this, and I can go Control L and it clears the screen. Cool little hack. So, awk is a record processing tool that was written by three guys with the last name Ahal, Kernighan, and Weinberger in 1977. It's just an acronym of their names. If you don't know who Brian Kernighan is, he's one of the guys who worked on C, the programming language, and the operating system. It became as a successor to SED and grep, and kind of takes a lot of the ideas and takes it to the next level. The way I look about it is that I think a good programmer uses the most powerful tool to solve a given problem, but a great programmer uses the simplest tool to solve a given program. And I think awk is one of the simplest tools for solving a lot of programs that people would generally default to solving in Python. So we're going to start off by checking what awk version we have. And so I have version 5.1. Anything from like 3 up will be fine, but definitely check that. If you are on home, if you're on Mac, brew install GAwk or GNU-awk will be the way to get the version of awk that's compatible with what we're going to do. And if you are one of those poor souls using Chocolatey on Windows, same thing, Choco install GAwk if you already have it. So the simplest thing we can do with awk is just pass it input and print it out. So we're going to do that by going, so normally if we go echo, let's say 1, 3, will give us 1, 2, 3. And if we pass that to awk, and like bash, awk uses brackets in a very similar way, and we pass it the print command, it does the same thing as echo. And that's the simplest use awk. It can print and does echoes, but the interesting part is where it gets better. So awk works on columns. So you can see we have 1, 2, 3. Awk calls these fields actually. We can get things out of 1, 2, or 3. So we can go, if I go awk and I go just like bash, $1, we get the first one. $2, we get the second. $3, we get the third one. That makes sense, right? Just like bash. However, we have some slightly more fancy things we can do. $0 gets us everything, and we're going to get later NF gets us the last one. Now, can anyone hazard a guess as to what NF stands for? This is just a fun question, doesn't actually mean anything. And unfortunately, because I can't see chat, you're going to have to unmute and scream at me. Anyone have any ideas as to what NF stands for? Okay, well, NF stands for the number of fields. So this is going to become important later. So the cool thing about awk is that it works across multiple lines of text too, unlike echo and some other functions. So if we go like echo, if I just like, how do I get multiple characters? I'm actually just going to have to paste in some text here because it's going to be very difficult to type out otherwise. So something I prepared earlier. So if we have this section of text here and we pass that to awk and we print the first field, we get 1 and 4 because those are the first fields on that record. So it's the first field in that record where a line is a record and a column is the field. We can also print more than one column, like so. So I would like you guys to have an experiment and see what combinations of columns and things you can print with different categories of data. And as we've already seen before, we can do. Now at this point, that's basically most of the awk that we're going to need for the del command. And in fact, that's most of awk that you're going to need to do a lot of things. It's just be able to get columns out. And most people are content with letting cut, sed, and grep do the rest for them. But awk goes a little bit further than that. Now, oh no, I do have chat. There we go. Cool. No one has sent. I just found chat, which is good. So I'm about to pass a command into the chat that if you wish to follow along by running these commands yourself, you're more than welcome to do. But so I found there's some very nice guides online for working through awk, and among them you find good data sets. And this is, in my opinion, a decent data set. It's just some Amazon book reviews, and I'm going to be using that. So you'll see here, I already have the book reviews. And if we cat book reviews, you can see it's just a massive thing. So I'm assuming that some of you might have worked in Pandas and Python for data reading workflows. And so if you haven't looked at awk before, I like looking at it from the perspective of doing this kind of thing. So just looking at the time, we're going to do a bit of a speed run, but we can go awk and let's print out the first $sign, and we give it the file we want as input, and I'm going to pass that to head. And there we go. That's the first field. And if we change that to 2, well, there's the second field, customer ID. In fact, we can look at a bunch of them. Now, the problem comes up when we try to look at things, because if you've used cut before, field separators are important. So if we print out 6, we get product title, but it's like things are looking a bit difficult. So like cut, sometimes we do need to specify a field separator, and that can be done with -F. And in this case, I'm going to do it as it's a tab separated file for TSV. What have I done wrong there? There we go. I forgot to put in a closing brace. We can make it tab separated, and there we go. We get some slightly better output. And I think for the last example that I'm going to show, I'm going to show 2 more examples. One is using NF in with arithmetic expressions, and I'll show you a basic pattern matching. So the last one we're going to do is you can use NF, which is the number of fields, and go back from the number of fields. So we can go, let's go to awk -F. We make things tab separated. And then we can go, let's take that and print. And remember, because we're in bash, we need a space between curly bracket and the thing we're going to do. We're going to print is the command. I'm going to print the last field, so NF. And then we're going to print a tab character. And then let's print, what should we do? I want someone to put in a chat a number between 1 and 7. Put it in chat. And that's what field? Okay, 4, that'll do. Let's go NF -4, and that's going to print the 4th column. And then space, and we get that, and pass that to head. We give it a sec. It's going to think about it. Or it's just going to break, which is, love that. Have I made a mistake? Don't think so. Oh, that's right. I forgot the $sign. Oh no, that should be fine. What have I done wrong? Anyone? Maybe if I take away the tab character, fix my problems.
Is it because you don't have the name of the file there?
Yep, that is exactly right. Exactly right. That's better. And there we go. We get the review date and review headline. And that's most of what you need to know for awk. The last one we're going to do is we're going to go do a quick pattern matching. So to do things in pattern matching, if you've used Vim before, you'll be familiar that using this slash characters is the same as pattern matching. So if I go, let's go echo AABBCC, and let's pass that to awk. And what we can do is we can search for the string BB, and because we're not doing this column wise, if I do okay, well, I prepared this earlier. If it was actually legitimately on separate lines, we would actually get the desired outcome, which is BB. So that's essentially how we do it. And if you want an example, can someone put in chat a popular book that you think might have been reviewed on Amazon at some point in time, and we'll see if it exists. To Kill a Mockingbird. You know what? I'm going to assume that's something from either English or English literature, to which I say respect. Also pain. So once again, we're going to do the field delimiter, and let's do a search for To Kill a Mockingbird. And we're going to go, because I know this data set well, and then we're going to evaluate an expression. So this is kind of how it was. So this character here is where we start our expression. We want to search for this, then we evaluate an expression, which is going to be print 6 and, well, I don't know, random number 8. And book reviews.ct. And I'm always going to pass things to head. And would you look at that? To Kill a Mockingbird has been found, and we've gotten the number of stars that's given on average. So there's obviously a number of different versions of that. And that's kind of how to use grep. We could also pass this to sort, and then we could also pass it to unique to get different levels of review. And there you go. You have a bunch of different ways to do things with awk. So we're going to move back to the del command now. Just before I move on, does anyone have any questions? Either put them in chat because I now worked out how to use that, or shout them at me. I prefer that if you shout them at me. Okay, well, I'm going to use my favorite text editor, Vim, to, let's go, what have I got? Recycle bin. So this is our favorite recycle bin. Don't mind the color scheme. I'm on Monero. Default color schemes are a bit scuffed. So let's go with where we were at. Where were we at? We were doing for file in all of the files. And we were at that particular point.
So I think up to implementing our -u.
Yes, the implementation of -u. So the -u is undo the most recently recycled files and most recently recycled files. All right, let's go. So we're going to start off by, first, we're obviously probably going to need the number of files that we have deleted. So I'm going to call that n, and I'm going to set that equal to being get number, because we've already defined the number, and we want to give it our option commands. That should give us the n. And so I'm going to go echo $n, and we're going to test it out. So what I'm going to do now is we're running a bit short on time, so I'm going to kind of merge in some of the process management stuff that we're going to cover a bit later, or maybe not if you just want to stay afterwards right now. So what I'm about to do is I'm about to press Control-Z in my Vim session. And what Control-Z does is it suspends the process. So I'm going to save, and I go Control-Z. So you'll see it says stopped there. Don't worry about the -clean bit in Vim. That just means no configuration. So Control-Z suspends the process. Now, if I go jobs, you'll see that I have a stopped Vim command. That means it's in the background, or it's suspended at the moment. So first what I'm going to do is I'm going to go, let's test our program. So let's go / of course, change mod. What is your problem? Still not executable. Big capital X. Okay, so now we can give it -u, and let's give it the last 4. Create a recycled directory like that, -u4, and it's not working. So as you can see, we have some things in the background. FG, or forget, means foreground, and that will just bring back the thing we were doing before. So if you ever recycling has changed and set it. Okay, this is fine. So echo.that. Let's go check it this time. That didn't do anything. What is going on?
We made the del command, not the recycle bin.shell command.
Yes.
Yes. Is that the command?
del-u4. You'll need to source, well, yeah.
Yeah.
And then del-u4.
Okay. So you notice I'm using make_p. No. Does touch have a -p thing? Okay, never mind. Okay.
So it's probably an error in the get number function if we're seeing an issue with the file creation.
Let's go. What does it want? It wants to. Okay, let's try that again. Bash GT, no. Undo the most recently GT unary operator expected. If I killed things.
So it's probably an error with get number, because that's performing a greater, less than comparison.
Let's see, -GT. What should get? Let me think. And log and option. That should be fine. I don't see why that's a problem. Let's just do a little deeper. Okay, let's go write the file, Control-Z to suspend. Source. Beautiful. I'm sure, del -4. -dt 0. Okay. Do I need to pass it a -L? Does anyone have any suggestions to what's going on here? Please, n gets number.
Dollars option. Case for -u dollars option.
Case for dash.
Well spotted.
Oh, it needs to be dollars option?
Yes, because it's a variable.
Oh, yes, this is true. I am good with bash.
That's amazing what you have trouble seeing when you're up there on the stage.
Absolutely. That's better. -u 0. Well, that doesn't seem ideal. Did I still change that?
It's
No,
echoing
that's-
the n below get number.
Ye- Yes.
So it's all
Well, this
ideal
should-
actually.
Actually, this should probably be one of these because we want to do it in the current shell context. I think. And you can see I'm struggling with that.
Well, it would be 0 because your log file currently contains 0 lines. So that's actually the expected output.
Okay, well, that makes sense.
You're at a disadvantage,
Okay.
David. Sorry.
Yeah, no, I am indeed at a disadvantage. Well, that's not going to stop me. So, going back
What you need to do
our
would be
dash
to
use.
create some files, delete them, populate the log file, and then you'll have something to look.
All right, let's go. All right. Let's do some classic bash expansion. So let's go touch random and actually I could do that's kind of dumb. I could there's some
Did you do the
some cheap-
dot syntax?
Yeah, yeah, you can. I'm just trying to think of the four-way. Okay, yeah, one. That's good. And let's go 3 to 6. Cool. And let's go. Oh, I probably shouldn't have used RM, should I have?
Yeah.
All right.
The point is to avoid permanent deletion.
Okay, let's go.
With cool.
Done 3, 4. Okay, Okay, now let's go del dash u. That's better. Forget.
Nice.
So we're about to run out of time, Edric. So do we want to keep
I
going? Or-
I think that we can pop in the, well, I think we could have enough time to pop in the awk needed to implement the restore command. And then I
Yeah,
think
right,
that might be
let's-
where we leave it. We'll note
All
there's
right.
a couple other sections on process management and so on, but before we go off, we'll just mention a few of the topics we could talk on more another day if you're interested.
So, well, the place that we're going to want to, all right, so if we're going to undo things, we need to find the place where we're getting things from, and then we need to find the place where we're getting things to. So let's go call this move from, and we notice how I'm putting this inside a list. So we're making this a list, and that's it's going to be the end. The last that from our dot recycle bin dir slash recycle log. And now here's the point at which we can use awk. So this gives us the last, in this case, it's going to be last 2 lines of our recycle log. We can pass that to awk, and we can give it, let's say, because tail is going to give us in the recycle log, it's going to give us a number of different columns. In this case, we're going to want to, well, let's just see what it gives us. Let's see what it gives us. Print, let's just give it print, and we're going to give it $0 for everything, and close those brackets. And I've forgotten that, and now we can go, but this line needs to be below there.
So move from, we want print 1.
Yeah, but let's just see what everything is, so we can see what's actually going to
Okay.
come out. Okay, move from, and let's go source del dash u4. So most and recently recycled files, we got nothing out of that.
That is our file size.
Yes, we got, because I'm going from yes. So if we go, so in this case, we're probably going to want to grab out, instead of 0, we're going to grab out the second one. So let's go, that's going to be our second one. And then this one, we're going to move to and replace that and make that 3. And so now we have
1
moved from,
and 2.
oh, sorry, 1, 2. That one, and now we can do this one. That seems good. Let's give it a go. Hey, that looks pretty reasonable to me. And we're not going to do because I forgot to do the suspending. And so that's essentially all the awk we're going to need to get to the move from the move to. And so now it's just going to be a simple case of looping over all of our values. And that's going to be just a simple for I. And now in this case, we're going to use a command substitution. Let's generate a sequence using sequence and from 0 to, and this is where once again, we're using the evaluate an arithmetic expression n, which is the number of -1 because we are indexing from 0. Let's do a do. And from this case, we're going to want to go this one in the current shell context move from, and because move from is an array, we can index it at the particular point which we need to index it at, and we want to move it to the destination directory, which is move to. And if anyone sees me doing a mistake whilst madly typing out, and that makes sense to that. So that's going to move all of our directories.
Yeah, just need
but
a done.
that will do a done because we don't need
Yeah.
to. We could do extra things about logging this, but that seems pretty reasonable.
And maybe remove
so-
the,
I think we'll just see how that goes. Let's see how
Yeah.
that goes. Let's go source sh delta -4 move cannot stat.
It should be 2 and 3 for the MV to and from. not
Yeah, I
1 and
thought it
2.
was 2 and 3, not 1 and 2.
oh, yes.
Yeah, I
Sorry,
thought that was the case.
my apologies.
All right, that's all good. And A. And now if we look at random 3, we have random 3 back. If we go RM random 3 and then, whoops, del random 2, and let's go delta -4, we get random 3 back. Delta -3, we also get random 3 back. We get random 2 back. And that's the del command working in some sense. Not ideal, but pretty reasonable. And once again, I forgot. I thought I did Control Z. But there we go. So is there any questions in chat?
Great. I think just to conclude the session, just we're going just a little bit over. Just want to show one final little step. If you have completed your del command and you wanted to make it into something that you can access every time you open your terminal. So I think David, I'm going to. It's all right with you. I'll just pull down the example
good.
and just run through this final configuration stage. So what I'm going to do now is just share my screen, share the terminal, and I'm just going to pull down the completed code from the GitHub repository, rename it, and then in this completed version, once it is sourced, you'll see that there's actually, this is good practice, the help function. So I can go del -- help and see the expected behavior. It's just a series of echo statements. Now, assuming that I'm so happy with this code that I want to use it in general, I can configure one of my user configuration files. So this file called .bashrc. And bashrc is the file that defines a lot of the aliases and environment variables that are loaded every time we start a new terminal session. So that's located in your user home directory. And you can head down to the bottom of this file. So as we go through, you'll actually see that there's already a lot of predefined variables, predefined aliases. So for instance, on Ubuntu systems, they often come with aliases for grep. So that's actually setting the color coding for grep and so on. But what we can do is just head to the bottom of our bashrc and then actually put in this command to source the recycle bin program. And that means that every time we start a new session, we will have that program available to us. So if I was to source bashrc now, given the correct file path. You can see that every time now we open the terminal, it'll load del, and it'll also give an echo to inform the user that we've actually loaded this non-standard function. So I think that's where we're going to leave things for today. A little bit over time. In the workshop, you'll see there are sections on process management and a little on aliases, and there's like a lot more we can cover. But hopefully this has given you a few tools you maybe haven't encountered before, or at least maybe space to think about some of the bash syntax that you may have been aware of, but maybe not found an excuse to use. And yeah, it's been a long day of training, so thanks for bearing with us. But yeah, please, this would be a great chance to ask any questions. If you need to head off, you can also just please feel free to duck off.
So if people want to stick around, very well, if people are interested, Edric, if this is all right, there's such a thing as ricing your shell or doing a bunch of other cool customization things. And
I think we
do
might
do this or not?
we may actually no, we'll keep recording. David, let's give us a tour of your of your terminal setup.
So this is just in case you're interested in what's happening. Here's what my shell looks like on your average day. And as you can see, things are happening. So this program that's got the fancy bars and graph is called HTOP. You'll find it on most Unix systems. It tells you what's running. If you haven't seen it before, it's pretty good. It tells you RAM, what processors are running, CPU usage, and that stuff. You can add colors to your LS and everything else. Vim, there's a bunch of configuration that you can do. I have ZSH set up such that I can have auto completed. So I think, do I have any Pawsey thing? I don't have anything that. There's also some important thing. You can set up your SSH configs to go. So for me, if I want to go to UCC at UWA, there's stuff that you can do. And there's also other places you can go as well. There's also some other cool, fun things that you might want to be able to do in your terminal. So at the moment, I'm in this thing called tmux. If you haven't heard what that is before, it's basically a way to have multiple shells open and terminal multiplexing at any given time. So here's another fancy process viewer. This is called bpytop or btop these days. It tells you your network interfaces. There's some funny things too. So you can have an aquarium, you can have the matrix, you can have a bonsai tree, and just as the last thing, Edric, you might want to stop recording this one just so they don't have to relive the pain that's going to be.
All right. See virtual people. Oh no, they can live through this.
Yeah, that just for you guys. Just for you guys. You can rickroll people in the terminal. It's great. And that's all from me. If you want to learn about terminal pricing stuff, just send me a message.
Hello.